Hi, I'm Utkarsh,
And I'm Anurika.
and Deepali is not with us.
This video aims to demonstrate the scattering of EM waves when different sized objects are placed in the vicinity of a point source.
There are a few bad jokes in there, so excuse us if you don't like any.
So Utkarsh, how have we demonstrated the scattering of EM waves?
To demonstrate the scattering of EM waves by different size objects, we have used a software called Meep, which simulates electromagnetic waves and their interactions by a computational method known as finite difference time domain.
Oh, so you place a point source and added metal objects of different lengths to simulate their interactions?
Precisely, and I noticed that the results were different for different sizes.
Oh really? What?
Let's just say I found a way of making an invisibility cloak. If the size of the object is much smaller than the wavelength of the source, then even if you look from behind the object, you won't realize any difference from the case when the object wasn't there. This can be shown by the GIF below, which was the output of the Meep simulation.
Oh wow. So suppose if there was an alien race who saw using radio waves, humans would automatically be invisible to them? That would be much better than even Harry Potter's invisibility cloak.
Moving on, as the size got larger, we started observing diffraction. You know what diffraction is, right?
Yes, diffraction can be described as the bending of waves around small obstacles and the spreading out of waves beyond small openings. Small here is of course related to the size of the wavelength. We generally talk about the diffraction of light waves, but rarely about diffraction of sound waves. You may not have realized, but you would have experienced diffraction of sound waves sometimes.
Really? When?
Let's take the example of a marching band, or for that matter, any sound producing over a wide range of audio spectrum. Suppose a marching band is approaching at a cross street. What sound will you hear first?
The low thump thump of the drum. Only later do you hear the trumpet and everything.
Yes, you would first hear the low frequency thump of the drum before you hear the high pitched sound of the trumpet. The reason for it is diffraction. Low frequency sounds have a longer wavelength and it will diffract more efficiently around the corner than the sounds from high frequency. Therefore, shorter wavelengths instruments.
Nice, I never realized that. Coming back to the experiment, this is the result obtained when the wavelength and object were of comparable size. As you can see, some amount of light does bend around the corners.
Yes. And what if the object is too big?
The fact that if the object is much larger than the wavelength, then the wave won't appear behind it is fairly intuitive. I mean, you really can't see through a big opaque door, right?
True. And that is what the GIF shows, right?
Yes, I hope this satisfies your queries. And even if the wave doesn't pass, I hope we do with an A grade. Hey. And here you can see the code we used. The parameters we mainly varied were about the size of the object. So, Anurika, I hope you understood the experiment.
Yes, waves interact with objects in their surroundings. When an EM wave comes across a very small metal object, it acts as if the object wasn't there and continues on. As the object size increases and becomes comparable to the size of the wavelength, we observe diffraction. An even larger object just crossed out the wave.
Yep, that summarizes it pretty well. Thanks for watching.